I'm the director of the Centre for Applied Climate Sciences at USQ, and we have approximately 20 staff in Southeast Queensland, Melbourne, and United Kingdom. And our main focus is to help people manage some of the risks they face from climate variability and climate change, and to help them seize any associated opportunities. And in order to do this, we conduct research, training, extension/training, product co-development, monitoring, evaluation, and adoption. And we also employ an additional network of 10 people across Northern Australia who we refer to as climate mates, who act as champions and advisors and consultants in the use of meteorological and climate science information in decision making. And in addition, we're fortunate to have around 15 PhD students across Australia and also in Southeast Asia. Now, before I introduce today's speaker, I'd like to, on behalf of USQ, acknowledge the traditional owners on the land on which we all gather, and we'd also like to pay our respects to elders past, present, and emerging. And it is my pleasure today to introduce Dr. Chris Hewitt, who is a Professor of Climate Science at the University of Southern Queensland. He's also Head of International Climate Services at the UK Met Office, and he's been central to developing the UN's Global Framework for Climate Services. He leads several European climate service projects, and in the past he was the WMO expert team. He was a co-chair of WMO expert teams on climate service user engagement and on tailoring climate information. And he's currently the co-chair of the expert team on climate information for decision making. And today he's going to be talking about climate services for managing societal risks. And after that, we'll have a 10-15 minute Q&A session. And in the meantime, if you have any questions, please pump them into the Q&A section. Thanks very much. Over to you, Chris.
Thank you very much, Scott. Let me try and successfully work the IT again. So I've been at the UK Met Office for decades now, actually. So as Scott said, I head up the International Climate Services team at the Met Office over here in the UK. That's half of my time. And then the other half of my time, yes, I'm very pleased to be working at the University of Southern Queensland with Scott and the team as Professor of Climate Science. Sadly though, because of lockdown, I've been stuck over here in the UK. So there's obviously tight travel rules between the UK and Australia. So I've been stuck here in the UK, but I may say a bit more about that later. So can you see everything now, Scott? Is this okay?
Perfect, thanks, Chris.
Okay, good. Here's an overview of what I'm going to talk about. I'll introduce the landscape of climate services, and I think this is nicely building on the two previous webinars, which I managed to watch recorded. Thank you, Crystal. I couldn't watch them live because of the time difference. And then I'll move on to talk about global activities, and Scott has introduced the ones that I've been active in recently. And then I'll give some examples from a few countries around the world to hopefully bring this all alive. So some building resilience to climate related risks and opportunities, as Scott rightly said. So climate services, climate information, it's already being used in decision making, risk management all around the world. It's been happening for a long time. I mean, by some measures, you could go back over 100 years, but it's really become quite a mainstream activity over the last 10 or so years, which I'll say more about later. And there's a lot of debate and discussion about what is a climate service. I don't intend on spending 40 minutes debating all the different definitions, but just giving here some scope rather than the definition. Climate services, to me, are about providing climate information to assist decision making. And then there are extra nuances that can be added in depending on the context, but that's broadly what I'm talking about here, providing climate information to assist decision making. These services, they do need to respond to user needs. We've heard about this in the two previous webinars, and those users, as it notes there, there's a broad range of users for these services: policymakers, decision makers, governments, was it national governments or local governments, the public sector, the private sector, the general public. They also use climate information to assist decision making, academia, and there's a long list of potential users here. I very much like what Andy Pittman said in his seminar, so I fully agree that they need to be based on scientifically credible information and expertise. This is very important. It's easy to say and it's hard to do, but that's certainly my view and other views, that the scientific credibility is very important. And then there needs to be appropriate engagement between the users of the service and the providers of the service, and I'll certainly say a bit more about that later. The picture there actually is the City of London, the River Thames, on a typical glorious sunny day in London. Every day is a sunny day in London. And that's a picture of a very large and expensive flood defence system. That's the Thames Barrier, and there's lots of other flood defence systems along the River Thames to protect the City of London. And this is just an example where the people who manage the barrier and our Environment Agency, they already have been using climate information for a long time. So there's an example, which I could talk about in the Q&A if you want, about how the information is used for flood management planning in the City of London. The timescales of interest, this is something I get asked a lot about at meetings around the world, and people have very strong views about what timescale is relevant for climate services. They're all about seasonal forecast services, or they're all about climate change adaptation. Well, I think if we go back to what I said before, climate information to assist decision making, they cover a wide range of timescales, depending on what it is that the decision maker, the user, is interested in. So I hope you can see the graphic on the right. This shows some timescales and some various different sort of applications or sectors that are interested on those timescales. So on the left, the most important timescale in my view for climate services is based on the current and past climate. So using climate observations, climate monitoring, producing climatologies. This is essential if you want to understand your vulnerability to current and past climates, how it's varied, and also as a baseline for any scenario planning for the future. So it's often tempting to jump over the importance of observations and monitoring, but for me, this is an essential part of climate services. And then I split it into two broad categories. There are multiple ways you could split it, but just to try and illustrate this is illustrative. So the first one is the near-term future climate, looking out months, seasons, and years into the future, perhaps out to a decade. And there's lots of interest from, for example, aid agencies and international development, market traders, people planning maintenance, insurance and reinsurance sector, people planning for resources around energy, water, food, for example, planning for operations. And these services are typically based on predictions from seasonal forecasts, for example. So looking out months, seasons, perhaps out to a decade ahead. So these are climate predictions that are often used to underpin the services. And then the other timescale I have is the longer term future climate. So based on multi-decadal climate change projections. And here obviously around mitigation policies, adaptation strategies, people planning large infrastructure projects, etc. So two more things to note on this diagram. There's often an overlap with weather services. So for example, people looking at planning for operations or planning resources, they will be probably interested in the coming days and weeks, and then perhaps out to months and seasons ahead. And so there are some services that would be useful if we can link through to weather services. And the other point to note is that it is not a discrete jump between these categories I've got here. Some of the interests cut across the categories. So adaptation strategies is an interesting example. Hopefully I'll have time to touch on later how the seasonal, seasonal to annual timescale is proving useful for helping build strategies for adaptation to climate change. This isn't new. Climate services are not new, as I said, and there's been a whole load of activities that have taken place that have got us to where we are today to be able to actually provide climate information for decision making. So I had the pleasure to work with a bunch of international colleagues a couple of years ago, and we produced a BAMS paper. And this is one of the figures that's taken from the BAMS paper. And this illustrates going back 1945, for example, the United Nations was established. This led to the creation of the World Meteorological Organization in 1950. And so the WMO has been instrumental in generating a lot of the capability and the international collaboration that have got us to where we are today. Moving forward, 1956, the first general circulation model was run, and this is often the basis, these models are the basis for many of the services. First weather satellite was launched in 1960, and these satellites have been very important for adding to the observational data sets we have. United Nations Environment Programme, a very important programme, was established in 72. 75, general circulation model was used to actually simulate the effects of doubling the atmospheric CO2 concentrations. And this obviously was a wake-up call for what's going to happen in the future as we increase CO2 and other greenhouse gases. Then in 1979, we had the first World Climate Conference. So these World Climate Conferences, there are 3 on this diagram, have been very instrumental in creating large international steps forward. So 1980, the World Climate Research Programme was established, for example, resulting from this first World Climate Conference. Moving forward, Montreal Protocol, another very important activity for the environment. And then in 1990, the second World Climate Conference. And now we have a flurry of activities. So the same year, we had the first assessment report of the Intergovernmental Panel on Climate Change. 1992, the Global Climate Observing System was established, and the United Nations Framework Convention on Climate Change was adopted. And all of these things were rising out of this Second World Climate Conference. Moving forward, Kyoto Protocol, Millennium Development Goals, Hyogo Framework. And now in 2009, this is where I guess I got involved in climate services quite heavily, was the Third World Climate Conference, which effectively was there to establish a global framework for climate services. So it's in recognition there's been a huge amount of work done beforehand where we have fantastic underpinning capability for climate services and a growing societal need for these services to help with decision makers and policy makers all around the world. 2 years later, a group of organisations, so the UK Met Office, NCAR, NOAA and the IRI in the US and the German Climate Service Centre established the first international conference on climate services, where we then created an international climate services partnership. So very much responding to the call which was coming from the Third World Climate Conference to advance climate services in parallel with this global framework for climate services. The GFCS, which I'll hopefully call it from now on, was established in 2012 formally under an intergovernmental board under the United Nations system. And then jumping forward, Sustainable Development Goals, the Sendai Framework, Paris Agreement signed, and then this rather unwelcome milestone of carbon dioxide passing 400 parts per million. So that was a rapid summary of however many years that is, 75 years. So this climate service landscape, it's not new, and it's now very active and very busy. And so the main global activities in this space, the GFCS, which I'll talk a little bit about later, and the Climate Services Partnership. So the GFCS is done under the United Nations system, quite a formal process. And the Climate Services Partnership is very informal. Anyone's welcome and able to join this partnership. And it does things because people want to do them. It's just like a community of practice. So feel free to Google that partnership. There are lots of things happening nationally and regionally. Australia is very active and the UK is very active. And there are large programs regionally. So for example, Scott mentioned some of the European Commission projects that I coordinate. There are very large investments in Europe on the underpinning capability in the climate services through this Horizon 2020 program, which is just finishing, and another program which is just starting in the coming months. There's the Copernicus Climate Change Service and many other activities. And it's not just Europe, but these are just some examples from Europe. And then there are lots of collaborations and partnerships. So this tiny diagram on the right here shows maps of regional climate outlook forums all around the world as one example. So in your part of the world, there's one called PICOF. So there are lots of these regional climate outlook forums, and it's a mechanism for forming collaboration and partnerships, but also for bringing the different actors together in a region to, in this case, look at seasonal forecasts for a particular region. And then finally, in this landscape, there's advances in climate science for climate services. And we have seen, and we're enjoying major advances. We've heard about some of these in the previous seminars. So climate monitoring, predicting and understanding of climate variability and climate change, there have been major steps forward, particularly through some of these large international and regional programs. We're seeing a lot more detail in the monitoring, predicting and understanding, assessing uncertainty, conducting risk assessments, looking at impacts, studying extremes, attribution of climate change, and the communication. It's a very challenging topic, and there have been major advances in all of these. And there's an illustration down here of the IPCC reports. And so we're just now starting to see the latest set of assessment reports come out from IPCC. And these are in a long series since 1990. So there have been major advances. Obviously, the actors in this list landscape are very important. So this figure here shows a value chain view, or some people prefer the phrase value web to show that there are multiple connections. And so our Roger Stone and myself wrote a paper, came out last month in Climate Services, and this is a figure taken from that paper to illustrate the landscape. So we've based it on Porter's value chain. This is work done back in the 1980s, where Porter talks about inbound logistics through to operations, outbound logistics, marketing and sales, and then the service, and then value at the user end. So in terms of climate services, we have this inbound logistics, which are the upstream capabilities, such as the climate observations, the climate research, the predictions and the projections. So we have this wealth of capability, data, information and knowledge, which we can use as our inbound logistics. Then the operational side, we have a lot of climate information, operational forecasts, so on seasonal forecasts. These are done operationally, such as the Australian Bureau of Meteorology and the UK Met Office and others. And in some ways, you could argue that the climate change projections, as an operational element to those as well. They're done on a particular timescale for the IPCC process through CMIP to certain quality standards. And then we come through, and then the various users require some downscaling of the information to a level more appropriate to their decisions, tailoring of some of the information to their decisions, or looking at impacts. Then sometimes there are very specialized services, perhaps translating that information using some sectoral expertise. And then on the right-hand side now, the delivery of the service, communications, and then the users. It's up to the users as to what the value is, but looking at the users' decisions and actions. So then we list some of the examples of who's involved in these. So interestingly, academia, perhaps more traditionally, it was more involved in the upstream capability. It's now we're seeing academia involved in all parts of this value chain. So there are some very strong groups, including obviously Centre for Applied Climate Sciences at USQ, who are involved in all of these parts of the value chain. National Met Services have been very strong on this value chain for weather services for a very long time. And many of these National Met Services are applying their capabilities and operational setup to climate services. And so lots of National Met Services are involved across this value chain. Not all are, same with academia, not all academia, not all National Met Services are active, but many, many are. International organisations and programmes, so I mentioned the World Climate Research Programme and the World Climate Observing System. So there are many international organisations and programmes which they're more active in this upstream part of the value chain, but there are many, many of these that are underway. There are some specific climate service providers that are not in National Met Services or in academia. I mentioned the German Climate Service Centre. That would be one example in Germany. It's not part of the German Weather Service. And there are other climate service providers around the world. Some organisations have their own in-house consultants. These are often more at the middle and right-hand end of this value chain. And similarly, there are consultancies that are springing up all around the world. Neil gave us a good example, I think it was last week. And so there are many, many consultancies that are operating in this value chain, and also industry bodies. And then I'll just list down here again the users at the right-hand side. So Roger and I also tried to look at risks and opportunities in terms of this landscape. So assessing climate related risks and opportunities. So the IPCC in their previous assessment report had a very useful diagram like this for assessing risks. It was based on hazards and vulnerability and exposure. And we've tried to couch this in terms of risks and opportunities, as Scott said at the beginning. That's what the centre does at USQ as well. And so here we had to try and avoid terminology which was necessarily negative, like a hazard. So there are climatic conditions, and some of these conditions could lead to positive or negative socioeconomic impact. So the same condition, for example, a heat wave and dry conditions in the UK, it could be very negative for agriculture, but it could be positive for tourism. And so the same climatic condition could create a risk or an opportunity, depending on your exposure to that condition and your susceptibility. So back to the global framework for climate services. So I guess it was about 10 years ago I wrote this vision now to enable society to manage better the risks and opportunities arising from climate variability and climate change using science-based climate information. And I think that vision 10 years on is still standing up as a very good vision, and the GFCS and others are certainly delivering to that vision. And here I tried to we flagged here that it's risks and opportunities. Now this is done under the United Nations system. The World Meteorological Organization coordinates this activity, but it is cross-UN. And there are various priority areas, which are sort of areas you would expect to see from the UN: agriculture and food security, water resource management, health, so the World Health Organization are actively involved, disaster risk reduction, and energy. And the way it's structured, recognizing there are many, many climate observations and monitoring data sets and information and knowledge, climate research, modeling and prediction. And there are active programs, as I mentioned, that are advancing these two boxes down the bottom here. This produces a lot of information. And so there's a layer called a climate services information system. So there's a huge amount of information which the users can then tap into to assist with their decision making. But this engagement between the users and the providers, so the underpinning capability, this, in my view and many other people's view, this user engagement is a key part of the GFCS. And so there's this box here called the user interface platform. So it's essentially the user engagement. So this is a very important part as to how to link the users to the capability and vice versa. So I think Scott just mentioned this. So I was very fortunate a few years ago, along with Roger Stone, to co-lead a WMO Commission for Climatology International Expert Team on user engagement for climate services. We had two very clear objectives for this expert team: identify and evaluate examples of user engagement, and then publish guidance on good practice with case studies of good examples. So this expert team was drawn from people all around the world, who then drew on their own networks. And we had lots of very useful discussions, and we produced a WMO publication, this green figure here, Guidance on Good Practice for Climate Services User Engagement. And then Roger and I, along with Andrew Tate, took the sort of the headlines from that WMO publication and added to it and produced a much shorter Nature Climate Change article. So an article that was more accessible than the WMO publication. But both of these had this diagram on the right here, which I think summarizes the work of the expert team, the conclusions and the recommendations. So start off, what are the user needs? And then there are multiple ways that there can be user engagement from forming decision based on those user needs. And so we worked with the WMO team to produce this very nice diagram. I think Roger refers to it as the stairway to heaven. So if we start at the bottom of this stairway, providing information. So we have three broad categories of user engagement here to illustrate this. So the bottom one here is information provision. So it's very passive engagement, perhaps based on websites and web tools. You can have a one-stop shop window. It's relatively easy to keep these up to date, although often people don't keep these up to date. So there are some challenges there, but it is easy to do so. You can have a wide range of products available. They're easy to use. The design can be user guided. Again, it isn't always, but be beneficial if it was, and they can be very intuitive. And for many people, this is all they really need. They receive the information and then they use that information in their decision making. Some users, however, want to have a more dialogue-based approach to user engagement. And here we could be looking at interactive group activities, so bringing groups together. You can have communications among the different people in the groups. And here you can start to build trust between the users of the service and the providers of the service. You can learn together from each other. You can develop and produce the services together, build up capacity within each of the groups, and you can regularly interact. And again, for many people, this is sufficient. They don't need any more than this. But for some people, they're after very tailored and very targeted climate services, very focused relationships. And so the engagement here is quite different. It's very time intensive and often can be costly as well. But you can produce bespoke climate services, have much more intense interaction, can be highly iterative. The data can be developed and provided to be directly usable by the user. You can have direct one-to-one contact and an in-depth understanding of each other. So it's not just the user understanding the provider, it's the provider understanding the user as well. And at the moment, I'm now leading an expert team with Lisa Alexander, who many of you probably know at UNSW. And here we're looking at climate information for decision making. So it is building on the user engagement, but it's slightly different. And we have 4 objectives. This is a much larger expert team. Firstly, to provide guidance and good practice on tailoring of climate information. And so this is work that we are currently doing at the moment. This is underway. We haven't finished any of this work. The previous slide I showed that expert team has finished, but this one is very much underway. Second one, we're looking to support country level delivery of climate services by producing some good practice guidance. So looking at national climate outlook forums and making recommendations on national frameworks for climate services. So a lot around collaboration and partnerships at the national level. Work that's not really underway yet, but about to start, is looking at guidance for regional approaches to climate risk management and effective user engagement. So building on the previous expert team I mentioned. And then the fourth one, which is definitely not my area, this is Lisa's area, to enhance the software tool ClimPact for sector-specific climate indices. So this is an expert team that's underway, so please do watch this space, and maybe I'll be able to give a talk on this in a year or two's time. But there are some principles that are appearing from these activities and other activities as well. So there's a lot of value in collaborating and having dialogue right across the value chain. So it's not just linking with the two adjacent parts on that value chain, but collaborating and communicating right across that value chain. So for example, taking the two extreme ends, the groups on the left-hand part of the diagram with the upstream capability would benefit from being able to understand what it is the decision makers and users are using that information for, and vice versa. The users and decision makers would very much benefit from understanding how we go about producing those data sets of observations or whatever they might be. In particular, co-production, so producing these climate services together, so not just the climate service provider producing something and pushing it out to the user, but producing these together, there can be many, many benefits, and I've just listed three there. So for example, working together, that enables the collaborations and the dialogue, obviously, and that can be very powerful. The services can be made much more useful and of much more value to the decision maker based on credible and salient knowledge. And it helps us to build trust between the different groups as well. And then the third principle here is importance and value of national and regional collaboration. So, for example, national frameworks for climate services, bringing together key stakeholders and key groups within a nation to develop and deliver and use climate services. And I've just got a picture down on the bottom right here of the Australian Climate Service, which I think Neil briefly mentioned last week. And so this is a service that's just been launched in Australia, and it's a good example. And there are many other examples around the world that are starting to appear where groups are starting to collaborate together. So now finally, I'll move on to the three examples. I have no idea how I'm doing on time, half past. So I have three examples from three different countries just to try and bring this alive. So the first one, this is work I'm doing at the UK Met Office and I've been doing for about the last 6 or 7 years, undertaking climate service development in China. So we're collaborating with the China Meteorological Administration, CMA. It's a huge national Met service. And we're collaborating with the Institute of Atmospheric Physics at the Chinese Academy of Sciences. And then there are many universities around the UK and around China who are involved in this collaboration as well. So this is a huge collaboration looking at climate research and climate services in China. And this one example here is where we developed a trial seasonal rainfall forecast service for the Yangtze River, which we've been doing since 2016. We're working closely with CMA and IAP and universities, but also with the Three Gorges Corporation and the China Yangtze Power Company, who are the companies in China who operate the hydropower facilities and the dams along the Yangtze River. And so the figure here shows the thick blue line is the Yangtze River. The red star here is the location of the Three Gorges Dam, which I think is still the world's largest hydropower facility. It certainly has been for a long time, if it's not now. And here is the city of Wuhan, which we all have heard, become more familiar with where that is. So we've been doing this service for, 5 years now. And the way this has come about is that the dams along this river have various responsibilities. But for example, the Three Gorges Dam, the Yangtze River has suffered catastrophic flooding throughout history. And some of the numbers are mind-boggling, of thousands, tens of thousands, if not hundreds of thousands of people who have died as a result of disastrous flooding in the Yangtze River when there's a huge amount of rainfall in that river basin. So the dam was primarily built to control those floods. You can't eliminate them. The river's too big and there's too much water, but you can reduce the disaster. So the dam is there to reduce the flooding, but it is a huge dam. There's a schematic on the right there of what the dam looks like. And so it's also used to produce hydropower, and it is a major producer of hydropower along with the other dams that have been built along the river. So those are the two main responsibilities. It's also there to make sure that the water supply, the quality of the water supply doesn't deteriorate, and this is a navigable river, so they have to worry about navigation on the river. So it's a very complicated setup for the operators of the dam. But clearly rainfall is a very important part of their decision making. So what happened was in late 2015, we happened to be taken there for a visit to the dam to hear about how they operate the dam and how they use seasonal forecasts. And we heard about their concerns, what they thought was working well and wasn't working well from the climate service that they were receiving. And it was very useful. We then happened to then move from that meeting at Three Gorges Dam via Wuhan to the regional climate center there to hear about their service, and then down to Nanjing, down near Shanghai, for our annual conference for this large program. And at that conference, we heard about some capability where the scientists were discovering drivers of extreme rainfall, seasonal rainfall, based on El Nino. And we were seeing a lot of capability and skill coming from the seasonal forecasts. And we saw that we had a need from the users and we had emerging capability. So we decided to develop this trial. So we produced a seasonal forecast of average rainfall and river flow in the Yangtze River Basin. So at first we were averaging over this large rectangular shape here and doing it as a seasonal average, disseminate this by the China Meteorological Administration. So with the UK Met Office, it's not appropriate for us to provide climate services in China. So we do this with and through the national climate service provider in China, and then they do that through their regional climate center in Wuhan. So as I say, this was motivated by El Nino, and at that time there was forecast to be a strong El Nino in 2015, 2016, and historically that had led to catastrophic flooding. So all of this has been published if you're interested in the papers. So what we then did was to develop a prototype climate service. So there's a diagram here, this is also a publication. Start off exploring what the user needs were. So we went to the Three Gorges Dam to here. There was science emerging, so exploit that science. So we developed a prototype service and then expose that prototype to the users. So we were very fortunate in May of 2016, just before the summer flood season, to be invited to the Yangtze River Basin Rainfall Consultation Conference. I think that's me there and a colleague next to me and a colleague presenting. And we're in the room with people who operate these hydropower facilities and meteorologists from Beijing, from the National Climate Center, and from the Wuhan Regional Climate Center and the local centers. And they're all discussing the coming flood season. And we're then able to show them our prototype and get some feedback from them, initial feedback about the prototype. Carrying on around this loop, then examine the service. So the verification of the forecast and the prototype, it was all over the news. So there was major flooding that summer in the Yangtze River Basin. The city of Wuhan was on red alert, that one showed. And the president got involved, but there was not a major disaster. The operators of the dams had prepared for the coming flood season. I'm not going to pretend that they took our prototype or our trial and that was the entire part of their decision making, but they were very honest with us that it influenced their decision making. It gave them some confidence in the decisions they were making before the flood season. So it fed into their decision making. And then in terms of then operating on that, and the next part of the diagram I had earlier was to operate on feedback. We were then very lucky to have visitors from the Three Gorges Corporation come over to the UK Met Office for 3 days, and we sat down in various meeting rooms with them and we presented the science and the service, explained its capabilities, its limitations and possible improvements. They were very honest about how good or bad or how useful or what value it was. We heard more about how the way they operate their decisions. And then we heard about how they would like to see this service improved. And there was a lot of demands that they had, which we couldn't meet, for having information at a very fine spatial scale or temporal scale. And we explained why we couldn't meet that, and they fully understood that. And so based on the feedback, we improved the capability. And the first step was to then split that large rectangle. We changed it to actually follow the river basin rather than a rectangle. And we split it into two halves, one above the Three Gorges Dam and one below the Three Gorges Dam. But we couldn't go further than that. The science just is not, seasonal forecasts are not able to be applied at an individual grid point. And that was as far as we could go with the science. And we carry on meeting with them and we carry on evolving the science and the service. Next example, the Drisk project in Southeast Asia. So this is a project that many of the people at USQ in the room there are involved in a lot more than I am. I had hoped to be involved, but the lockdown has completely prevented me actually going out to Southeast Asia, obviously. Anyway, I've been involved in calls remotely. So this is a project which the WMO are leading along with USQ and SEAT. It's looking at applying seasonal climate forecasting and innovative insurance solutions to climate risk management for agriculture in Southeast Asia. And this is a snapshot from Torben's excellent website, which I encourage you all to look at if you're not familiar with this. And it's undertaking climate risk management. But for me, one of the things I wanted to flag here is that, from what I'm hearing, there's a very innovative use of seasonal timescale here as a stepping stone for climate change adaptation. So engaging with the farmers, for example, obviously climate and climate change and seasonal forecasts, that's not their area of expertise, but this project is engaging with them and managing to communicate seasonal forecast information. So they're getting more aware of climate variability and climate change, understanding it better and seeing how it can be used in their decision making. And I think it's a very, very good example of how this seasonal timescale can mean something to the decision makers on the ground and also help them get ready for climate change, for adapting to climate change. So please do look at the website if you're interested in more details. And then the third example, I'm based in the UK, so I really should talk very briefly about a project in the UK or work in the UK. So there's a global state of the climate report produced every year, and then some regions have a regional state of the climate report. And then we have been doing a UK one for quite a long time. This is just an example of the state of the UK climate in 2019. So there's some nice infographics that the Met Office produce, and it shows a whole load of information. So on the left here are these so-called climate stripes. And this is illustrating that all of the top 10 warmest years for the UK have occurred since 2002. I mean, it's pretty striking. And this is available for anybody. So the general public, governments, industry, anyone in the UK who's interested in this. And it's a very accessible way of illustrating lots of the other things on here. So in 2019, 4 high temperature records were broken, highest UK winter temperature on record so far. For example, above average sunshine hours. Yes, the sun does shine here. For example, many, many things on here. And the other one I wanted to highlight in the UK is the UK National Climate Change Projections. So UK CP18 are our most recent ones. This is a collaboration between the UK's Environment Agency, the Met Office Hadley Centre, and 2 UK government departments, Department for Environment, Food and Rural Affairs, and Department for Business, Energy and Industrial Strategy. So these are our national climate projections, which we've been producing and updating for, I don't know now, 10, 15, 20 years. They provide an outlook on the changing climate in the UK until the end of the century and beyond for some measures. And they provide the most up-to-date picture of climate change in the UK. The projections have been developed using cutting-edge science delivered by the Met Office Hadley Centre, and this is in collaboration with many groups around the UK and around the world. This science is not just something that one organisation does, it's big collaboration, but this is delivered by the Met Office. And then there's a major undertaking with the peer review of this with an international and independent panel. So there's a UK CP18 peer review panel, the great and good around the UK, Europe and the world. There's a government user group involved and a non-government user group. The project team is the 4 organisations, and then there's a Met Office delivery team. And then what happens is that the data comes out, and this data is available for users to climate-proof their decisions or assess their impacts, and they can look at risks or opportunities based on this data. So I'm coming to the end now. Quick time check. So some challenges for climate services. This is one I think Roger Stone keeps on saying to me, and I like this first one. It's only worth delivering climate service if it's going to be used to influence an outcome. And I think that is a good point to remember at the back of our minds as we develop climate services. Coordination and engagement is very beneficial, but it's hugely time consuming. And there is a major challenge there on how to coordinate and engage effectively and efficiently. There's often a big gap between the requirements from the decision makers compared to what it is that these scientists are actually able to meet those requirements. And Tanya and Andy's paper and seminar certainly highlighted this, and that is a huge gap. And we just need to be honest about that gap. We shouldn't be shy of it or afraid of it. We need to try and narrow that gap, although as we narrow it, the user's requirements often then become more demanding, but that's an ongoing dialogue, but it is a major challenge. Who are the users? There's a challenge there. Who are they? What do they need? So even when you find out who they are, how do you find out what they need? They might not even know what they need, and it can be very difficult engaging with users. Other disciplines. So I'm a meteorologist by training, maths degree and then meteorology, masters and PhD. But there are many other disciplines that are needed for climate services for decision making. For example, social science. And so a recent paper came out a week or 2 ago by Findlater et al. Climate services promise better decisions, but mainly focused on better data. So I think those authors are all social scientists, and it was funded under a social science program in Canada. And I think the reviewers were all social scientists, but the points are well made. That it's not just something that one discipline can do, and we need to involve other disciplines, not just social science. Economics are important, but many other disciplines need to be considered, and that is a major challenge. And then finally, the challenge between the capabilities and the capacities of both the providers and the users. We need to improve all of those. I think this is the final slide. So what next? I think we need to further develop those capabilities and capacities, but across the entire value chain. It's not just trying to improve the capabilities and capacities of the climate service providers or the users, it's everyone in the value chain. I think the science needs to develop a lot further. We've seen major advances, but clearly we need to improve that because this underpins the services. It needs to be more innovative, and the services themselves need to improve to better meet societal needs. Partnerships need to be improved and strengthen engagement between the actors right across the value chain. And user engagement, this user interface, this is still a key issue. The management of climate information needs to be developed further. We have a huge amount of information. How do we manage that? How do we improve its uptake, and how do we improve its use? And then national frameworks for climate services as an opportunity for nations to either start to develop them or improve development. So in Australia, there are activities underway, and in the UK, we need to further develop these within our own countries, but also all around the world. Regionally and nationally, there are climate outlook forums at the moment to look at seasonal forecasts, but I think there's an opportunity to get away from just talking about seasonal forecasts. If the users are interested in seasonal timescales, that's great. If they're interested in climate change, then that's great. So we need forums to consider all of the parts, all of the timescales for climate. So that's an area that needs to be thought about more, and all of this needs sustained funding. I think I might have slightly overrun, but thank you very much for listening, and I will stop there and hopefully we have time for questions. Shall I stop sharing my screen, Scott?
Yes, please, Chris. Thank you very much, Chris, for a great talk, reflecting extraordinarily broad and deep international engagement. I'd now like to pass over to Hannah Heidemann and Louis Cuadio to moderate the Q&A session. Thanks, Hannah and Louis.
Scott. So the first question for Chris is if your slides can be shared after the event, so a few people have asked that.
Yes, I realised there was some of the things I referred to, I hadn't got web links. So yes, you can share the slides, and if people wanted some of those web links, then maybe drop me an email like the WMO publication, or Google it. When you have the slides, I guess they can then Google some of those links. So yes, please do share the slides. That's not a problem.
Thanks very much for that, Chris. And I just point out too that Chris has already kindly agreed to allow us to share the video of the presentation. So we'll be putting that up on our soon to be established channel, YouTube channel. So look out for that.
So I've watched the other two ones on video, so that's been fantastic for me. So it would be a bit hypocritical to not allow you to do that for me as well. So yes, please do share the video. It's been great for me to watch the other two. So hopefully some people will then watch this one.
Great. Thanks, Chris. Thanks.
The next one is more a comment rather than a question from Pandora Hope. It would be good to hear a bit more about the regional climate service groups you mentioned within the tiny map, and particularly in the Australian region.
Hi, Pandora. I haven't met you for a long time. Yeah, the word regional is very unfortunate there, actually, and I'm sorry I slipped into that mistake. So for some people, regional means across multiple nations, and some people regional means region within a nation. Apologies. So the China example, when they talk about regional climate centers, Wuhan is the regional climate center for a region of China. And I'm not sure what the situation is in Australia. I'm not sure what a regional center, I'm not sure if they're within Australia or if it's a region in like the South Pacific. So I'm sorry, my knowledge is a bit remiss there. But so what was the question then? Sorry, in terms of regional?
Yeah. Particularly for the Australian region, what the regional climate services groups are, a bit more details about them.
Yeah, so I'm not the right person to ask that question to. That would probably be people at the Australian Bureau of Meteorology. I guess they have regional centres around Australia. Unless anybody else on the call happens to know, I don't know what the Australian Bureau of Meteorology does. In Europe, the equivalent would be within the UK. We have regional groups within the UK, but when we talk about region over here, we normally mean Europe itself. So in Europe, we have, for example, the European Centre for Medium Range Weather Forecasting, which hosts this Copernicus Climate Change Service. So Pandora, the Copernicus Climate Change Service, does have data available all around the world, actually. So it would be worth looking at the Copernicus Climate Change Service as well. I think Pandora is at the Australian Bureau of Meteorology, so she probably knows the answer to this question better than I do. I don't know the answer to that question, sorry.
And another comment also from Pandora Hope is that the figure from Hewitt et al. 2020 is a great figure, and that it would be great to add the International Geophysical Year in 1957-98 to that as well.
Yes, that's a good idea. Thank you. Thank you.
The next question is from Anu. Wasn't the Three Gorges Dam primarily for storage to reduce flow of rivers in Southeast Asia? And do you think Australia should be looking for one such dam in the near future?
Excellent. So the Three Gorges Dam, so no, the Yangtze River doesn't flow into Southeast Asia. So the Three Gorges Dam is on the Yangtze River, which flows out at Shanghai, effectively into the Western Pacific. So I'm not sure which dam it is that will be used to block various rivers that flow into Southeast Asia, but that's not the Three Gorges Dam, no. In terms of Australia, yeah, it's easy for me to say. So yes, surely the government could build some hydropower facilities in Australia. I'm sure there are some anyway, but it's not, I mean, the Three Gorges Dam itself, I don't want to get too political here, but it was controversial at the time when it was built. It is a huge dam, and it raised the level of the river behind the dam by, I can't remember what the number is, of the order of 100 meters. And so there were lots of towns and villages were displaced, and cities actually, upstream of the Three Gorges Dam. And so the cities were relocated, a major relocation and building program that China undertook a few decades ago. So building these dams is not something that you can just easily do. So I shouldn't have been flippant and lighthearted there, but I'm sure that governments around the world do think about these facilities. It's a form of renewable energy, obviously. And in China, it's a huge form of renewable energy. They have a huge amount of water flowing down their major rivers. And I don't know how much potential there is for the rivers in Australia. That's not my area of expertise. Obviously a lot less than there is in China, because the Yangtze is an enormous river and Australia doesn't have such large rivers. But yeah, I would imagine that the Australian government look at this as part of the mix for renewable energy. Solar power, wind power as well would be other examples. And hydropower is one part of the mix. But probably in Australia, it's a relatively small part. I should think that solar power is a lot more potential, given how sunny it always is in Australia, I hear.
Yeah, the next question is from Dukan. He's asking, one of the challenge for climate services is the spatial resolution below the grid cell. What is your view about this? Yeah,
hi, Duke. So I think it was Andy Pittman talked about this, and I agree that we've got to be very cautious, and I've flagged this at some of the Drisk meetings where Dukan and I worked together with others. So yeah, so from the global climate models, for example, the resolution that those models are run at is pretty coarse, 60 kilometers resolution at best, and typically more than 100 kilometers. So the grid boxes that make up those models have a resolution which is pretty coarse and may not be useful for many applications. And you wouldn't use, as Andy rightly said, the scientists who develop and use those models wouldn't expect a decision maker to be taking a grid point and using that data to then drive any decisions. And so these models are intended to be used at the largest scale, so you're aggregating against lots of grid boxes. So the Yangtze River example I showed, we have a very large area that we average across. The Yangtze River basin is a huge basin, it's absolutely enormous. So we average across that basin. We don't take information from the individual grid boxes that make up that. And so the same applies to answer Ducan's question as well. So the global climate models, they're not intended to be used at the individual grid box, and those grid boxes are 100 kilometers or so, that sort of size. So I think Andy talked about this as well. There's lots of work done with downscaling. So there are dynamical downscaling where people then use a model over a limited domain, a regional climate model, to get finer resolution. And these are being run at, well, typically 25 kilometers, but people are now running a much higher resolution, down to perhaps 1 or 2 kilometers resolution. And these are now starting to resolve convective scale processes, for example, which are very important. And so there's a role for downscaling, and I might not agree on that role. So there's dynamical downscaling using these regional climate models, and then there's statistical techniques as well. So people do downscale using statistical techniques, and Andy gave a very nice discussion of this. So it's worth looking at his seminar from a few weeks ago. So that then gets you down to a finer scale, but there are some challenges going from this global general circulation model at the poor scale down to these finer scales. There are challenges there. And even then, that's probably not at the right scale that lots of decision makers need, because again, you wouldn't just use an individual grid box from these regional climate models. So Ducan's right, it's a major challenge getting from the climate model resolution to the resolution that the decision makers want. But that's where I think this power of the engagement between the users and the providers and others across the value chain is really important, to be able to explain these limitations. So when we had the visitors from the Three Gorges Corporation come to visit us at the Met Office, we were able to explain all of this for many hours. I'm rapidly racing through it in 2 or 3 minutes with this answer, but we spent hours discussing it with them, and they had a much better understanding, and we understood what this then meant for them, and tried to then see what information we could provide at a scale that we were comfortable from the science. And individual grid box is not a scale that is something that the scientists are comfortable at. And as I say, even that often isn't high enough for the users and decision makers. So sorry, it's a big challenge, and we just need to be honest about it.
Great, thanks, Chris. One more question for you. If you had one wish that could be granted to help improve global climate services, what would you wish for?
I'm now biased by my previous question and answer. I think improving that underpinning capability, of which a major challenge is the resolution. It's not the only challenge. There's also trying to understand climate variability and climate change and processes. But yeah, I'm probably biased by that previous question, but as a rapid answer, it's improving that underpinning capability, and that issue around resolution and being able to actually extract information that we're comfortable with at a suitable resolution. That would be a wish. I would have others if I thought about it more, but like I say, I think I'm biased by that previous question.
Thanks. One last question by Keith Swans.
Oh, sorry, Hannah. I might jump in there. Might have to wrap that up. Thanks. Sorry to interrupt. And thanks very much for moderating the Q&A. And thanks also to you, Louis. And special thanks to Crystal for organising the event, and also for Chris for a wonderful presentation. And I'd also like to thank the many participants, especially those of you who engaged in the Q&A. And I was very interested in the discussion near the end initiated by Ducan on downscaling, because our next speaker will be a world leader in downscaling, Professor Jason Evans from UNSW, and he'll be talking about downscaling climate change projections. And that seminar will be on Wednesday, the 20th of October at 10 a.m. So thanks again, everybody.
Thank you. Have a good evening.
Thanks.